In this example, we're going to look at solving this question by integration by parts. The indication that this is integration by parts is it's a product. There's no u substitution that we can make. And one of the terms of the product is a trig function, the other is a polynomial. So it's actually going to be easier to solve this, or faster anyway, by using the table form of integration by parts. So we need to choose u, something that we want to differentiate and make easier, and du is something that we can easily, or pardon me, dv is something we can easily take the integral of. So in this case, u will be x cubed because every time we take the derivative, it becomes simpler. In the table form here, we keep taking the derivative until we get to 0. Now we integrate cosine of x the same number of times. So the integral of cosine is sine. The integral of sine is negative cosine. The integral of negative cosine is negative sine. And the integral of negative sine is cosine. Most people find it easier to differentiate and get the negatives right, so just as a check, if we start at the bottom, we should be able to take the derivative and get each of these. So the derivative of cosine, negative sine. Derivative of sine is cosine, so with the negative we get negative cosine. Derivative of cosine, negative sine, negative negative, positive, and derivative of sine, cosine. So we are right in this column as well. Now, when we're using table, we are really using the formula, except we're using it all at once. So it's positive, then negative, and we'll keep repeating that pattern. Positive, negative, positive, negative, positive. And we multiply on the diagonal, and we integrate across the bottom. So multiply those terms, integrate the product of those. And that will let us write our answer. So we end up with this integral equaling x cubed times sine x. Minus and minus gives plus 3x squared cosine x. Positive and negative gives minus 6x sine x. Negative and positive give minus 6 cosine x. Positive, the integral, or so plus the integral of 0 times cosine. The integral of 0 is a constant, so plus c. And there's our final answer. We'll continue now with another example, a little different form. We're going to do the integral of sine inverse, and this is also done using integration by parts. Easier to do this one using the equation here. So we'll choose u and dv. The parts we can consider here are the sine inverse and the dx. Now, we can't choose sine inverse for dv because then we'd have to integrate it. We don't know what the integral is. That's actually the question. So we do know the derivative, and the derivative does get rid of the sine inverse, so that does make it easier. And we can easily integrate dx. So the integral of dx is x. The derivative of u, so the derivative of sine inverse, is 1 over the square root of 1 minus x squared. So now we'll put the pieces in and see what we get. U times v, so u times v is x sine inverse of x minus the integral of v du. We do need a dx here. So v is x over root 1 minus x squared dx. Now this is just another integral. All the integration by parts does is give us an integral that we need to solve that hopefully is easier. Hopefully you can notice here as well that 1 minus x squared If you set that equal to u, du is minus 2x dx. We have x dx, so that'll work fine. So what we're going to do is write the integral using u substitution. Just to keep it separate from this u here, I'm actually going to call it t substitution here. It's just a letter, it doesn't matter what you call it. So t equal to the part under the root in the denominator, then dt is equal to negative 2x dx. Solving for x dx, since that's the part that we have here, dt over minus 2 equals x dx. Substituting in here then, we get minus 1 over 2 multiplied by t to the minus a half. This is t, it's in the bottom, so we'll take it up top. So minus a half dt. Integrating then, we get plus 1 over 2. We take the half out first. Minus minus gives plus a half. T to the minus half becomes t to the positive half over a half plus c. We need to replace t with our x and also simplify. A half and a half can cancel, and we're left with x sine inverse of x plus the square root of 1 minus x squared plus a constant. So that's the integral of sine inverse of x.